Einstein's principle of equivalence is the foundation of his general relativity theory. It does not belong to him. In fact, it is an adaptation of Newton's corollary 6.
If bodies, anyhow moved among themselves, are urged in the direction of parallel lines by equal accelerative forces, they will all continue to move among themselves, after the same manner as if they had been urged by no such forces.
Einstein made it.
The gravitational field has only a relative existence, because for an observer falling freely from the roof of a house there exists no gravitational field. Indeed, if the observer drops some bodies, then these remain relative to him in a state of rest or of uniform motion.
Obviously, in Einstein's principle the gravity plays the role of Newton's equal accelerative forces, thus, this principle is a special case of Newton's conclusion. Einstein generalized the principle of equivalence to all phenomena. In reality, it fails by the light. We consider his thought experiment more accurately. In terrestrial laboratory, a light beam sent in horizontal direction, the same is done in the accelerated space laboratory. The ray of light in the terrestrial laboratory is deflected through the interaction with the gravitational field to the ground. It expects same phenomenon at an accelerated space laboratory. This is true, but not exactly. The light beam in the gravitational field would be bent more towards the ground than in an accelerated rocket. It is because the interaction of the light beam with the gravitational field takes place in every point of space. In this way, the light beam always changes its direction of movement in the direction of attractive mass. In an accelerated rocket, on the other hand, the light beam moves freely and always in the same direction because no external forces act on it during the flight to the other wall of the rocket. The information, whether the rocket accelerates at this time or moves unaccelerated, is not transmitted to the light beam. In this way, its orbit is less curved than in the gravitational field with the same acceleration. Therefore, in principle, there can be no perfect equivalency between gravity and acceleration. No matter how small a piece of space is, this discrepancy will always be there.